Welcome to Smarter, Faster, Fairer, Machine Learning's New Wave. In this episode, we explore 84 groundbreaking studies published in the machine learning category on June 5, 2025. Join us as we unpack breakthrough trends, techniques, and the real-world impact of today's most influential research. Whether you're a seasoned researcher or simply eye-curious, this journey into the future of digital intelligence is designed for you. Here's what you can expect from today's presentation. A comprehensive journey through 84 recent machine learning papers, highlighting key research themes such as efficiency, interpretability, and robustness. We'll spotlight 3 seminal papers that are actively shaping the field, examine technical advances and their relevance in practice, and preview future directions and open challenges in artificial intelligence. Machine learning serves as the driving force behind virtual assistants, healthcare innovations, and smart devices. At its core, this field merges mathematics, code, and vast data to solve real-world problems. Advances in machine learning fuel progress in automation, prediction, and decision-making, connecting theoretical foundations, optimization techniques, and practical deployment strategies. As a result, machine learning stands as a foundational pillar in the ongoing AI transformation across diverse industries. Efficiency and scalability have emerged as dominant themes in current machine learning research. Handling large-scale models within limited memory constraints remains a top priority. Notably, Adrian Łańcucki and colleagues have proposed dynamic memory sparsification for optimizing inference, while Łańcucki and collaborators introduce the kinetic scaling law for hardware-aware model design. Techniques such as sparse attention and cache compression are enhancing real-world usability, enabling longer conversations and broadening access to advanced AI capabilities. Transformers continue to be essential for modeling sequences by capturing long-range dependencies in data. However, their reliance on large key-value caches places significant demands on memory resources. Memory sparsification techniques help reduce storage requirements while preserving contextual information. Additionally, advances in attention mechanisms allow for efficient processing of longer sequences. These optimizations are instrumental in making large-scale models viable for a wider range of users and applications. Interpretability and transparency stand at the forefront of artificial intelligence research. Models must be able to explain their decisions clearly to foster trust and accountability. Shijian Xu and co-authors introduce NeMo, a nonlinear interpretable model that balances clarity and accuracy. Hybrid modeling approaches maintain transparency while enhancing predictive power. Antonio Almodovar and colleagues also explore the development of explainable predictive systems. The growing demand for transparency is especially pronounced in high-stakes application domains. Robustness and generalization are critical for deploying AI in real-world environments, where data is often incomplete or noisy. Maxwell Xu and collaborators address these challenges with LSM2, a model designed to handle missing wearable sensor data. Adaptive self-supervision enables learning from fragmented datasets, ensuring that models remain robust outside controlled laboratory conditions. The principle of generalization underpins the reliability of AI systems across diverse and unpredictable settings. Diffusion models and self-supervised learning have become central technical concepts in modern AI. Diffusion models gradually transform random noise into realistic outputs, serving as powerful tools for generating images, text, and time series data. Self-supervised learning methods allow models to build robust representations without explicit labels, enhancing data efficiency and adaptability. Together, these approaches contribute to the development of robust, flexible, and data-efficient AI systems. Several critical insights emerge from this collection of research. Inference timescaling is reshaping deployment strategies, as demonstrated by Łańcucki and colleagues. Smarter resource allocation, rather than merely increasing model size, yields superior performance, a key finding by Sadekhan et al. Studies by Xu and collaborators confirm that interpretability and predictive accuracy can coexist. Further, robust learning from incomplete data is now considered a baseline expectation, and fair, efficient data valuation, as addressed by Sun et al., has become essential for responsible AI development. Progress in machine learning is driven by a synthesis of advanced methodologies. Transformers remain foundational for sequence modeling. Sparse attention and quantization techniques optimize memory usage, while diffusion, self-supervised, and contrastive learning methods enhance representation power. Kernel and energy-based approaches are regaining prominence for improving robustness and interpretability. Throughout, rigorous theoretical analysis, including convergence proofs and complexity bounds, ensures that models are both reliable and predictable. A closer look at the paper, Inference Time Hyperscaling with KV Cache Compression, by Adrian Łańcucki and colleagues reveals practical solutions to memory bottlenecks in large language models. The authors introduce dynamic memory sparsification for inference optimization, achieving up to 8-fold cache compression with minimal loss in accuracy. This enables longer, more coherent outputs from models and facilitates broader, more efficient AI deployment. The approach is selected for its immediate and significant real-world impact. The paper, Kinetics, Rethinking Test Time Scaling Laws, authored by Ranajoy Sadekhan and collaborators, proposes the kinetic scaling law to enhance inference efficiency. The work highlights the substantial memory costs associated with attention mechanisms in large models. Sparse attention architectures are shown to outperform dense counterparts when handling long sequences. This research guides hardware-aware model design and challenges traditional scaling paradigms, making it a pivotal contribution to both theory and practice. Turning to NeMo, a nonlinear interpretable model, by Shijian Xu et al. The paper presents a hybrid architecture that integrates the interpretability of linear models with the flexibility of neural networks. The model maintains transparency while improving predictive accuracy through the use of profile likelihood and adaptive ridge regression for optimization. Validation on both synthetic and real-world datasets demonstrates that NeMo successfully bridges the gap between trust and performance, setting a new benchmark for interpretable and powerful AI. Looking ahead, several future directions and open challenges become apparent. There is an ongoing push to develop efficient and scalable models tailored for resource-constrained environments. Transparency, fairness, and explainability in AI are receiving increased attention. Robustness to imperfect or adversarial data remains a critical research focus. New theoretical tools are being developed for crafting reliable and generalizable algorithms. Additionally, advancements in debugging, monitoring, and data valuation techniques are expected to further enhance the safe and effective deployment of machine learning systems. This synthesis was constructed with careful attention to transparency and methodological rigor. The summarization and analysis were powered by GPT 4.1 from OpenAI, with Google TTS technology providing audio narration. Visual materials were generated using Grok image tools, and all content and references underwent expert human review. While every effort has been made to ensure completeness, some oversights may remain. Listeners are encouraged to consult the included references for comprehensive details. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.